This chapter is pretty much a repeat of what you saw in Windows 10. A lot of similar functionality, a lot of similar interaction with Hyper-V that you can do within the server. So we covered already what a VM is, the guest OS, who the host computer is, and virtualization software. You have the hypervisor. And there are the two types, type 1 and 2. We have our virtual disks, which are nothing more than files. Our virtual networks, which are all happening within the CPU. And Checkpoint is Microsoft's way of saying snapshot. So if you are familiar with VirtualBox and VMware, you see it as snapshot. Microsoft wants to be cool and call theirs Checkpoint. Here is a Hyper-V type 1, where the hypervisor is the operating system running on the hardware. A type 2 would be Windows Server is the operating system installed, and we have virtual machines running on that, like VMware Workstation. That is a type 2. Of course, it doesn't just work on any system. You have to have 64-bit. The CPU needs to have virtualization enabled. You have to have enough free disk space to run virtual machines and enough RAM to run these VMs. That's Hyper-V. Again, looks just the same as Windows 10, no surprise. You can install it either through Server Manager or through PowerShell. You can also manage Hyper-V remotely with the RSAT tools. So you don't have to run this from, you don't have to get to this through the local system. You could do it, remote. We'll get to the over provisioning as we go. There are some slides that cover a little bit on that. Just remember that ESXi is more of the gold standard in virtualization. So like I said, you can manage servers remotely through PowerShell or through the MMC. You'll need to enable that remote connection in order to get to that system. Just a note, if you are running server, not the Hyper-V only, then you'll be able, and as a standard edition, you'll be able to run 2 instances of server. If you're running data center, it would be unlimited. Of course, there's a price difference between standard and data center. It is possible to upgrade your virtual machines from an older edition up to a current, just as you can with any other system. So it is possible to take a VM that you made in Server 2008 and bring it up to 16 and 19. Creating a VM, again, we've covered this before, so this is really repeat for you in the process to create either a Gen 1 or Gen 2 VM and the advantages of Gen 1 versus Gen 2. Of course, you can access a VM either through the network if it's connected and set to be remotely configured through like SSH or something, or access it directly from the Hyper-V manager. Here's your standard look of a Hyper-V running a Windows system and all your actions that you have on the right, similar as you have with Windows 10. The options that you see when you are in a VM connection, when you have the GUI up, like Control-Alt-Delete or the start, turn off, all the similar things that you see in any hypervisor, really. Of course, a couple tasks. Again, this more depends on which hypervisor you're using. And just as with server, you can import and export VMs. Exporting and importing is all a piece of cake. You can export without shutting down a VM, but it's probably a good idea to turn it off and then export. The import is just the reverse. You can copy a virtual disk from one system to another because, again, it's nothing more than a file. So it is totally possible. Just know that you'd have to create a new VM through the wizard or through PowerShell and then add that disk to that VM to run it. Using things like the MS Center Virtual Machine Manager, you can take a physical machine and turn it virtual. This is useful when working with older systems that for whatever reason you need to keep up. You can turn that physical machine who has dying parts and make it virtual so that it still works, so that whatever that application or whatever functionality still happens just virtually. Now, covered this before. The Gen 1s have MBR and have more limited resources. Your Gen 2s can do more, like network boot with IPv6, GPT boot, UEFI, secure boot, and so on. So Gen 1 is great for older Windows or older operating systems, whereas Gen 2 is great for the newer. Changing settings. If you want to boot to a different drive with Gen 1, it's in the BIOS. With Gen 2, it's the firmware. There's the BIOS. There's firmware. So again, one difference between Gen 1 and Gen 2. Gen 2s can do secure boot and enable encryption support. So if your virtual machines are going to handle sensitive data and you want to ensure that they are encrypted, Gen 2 will be the way to go. And it's under security. Memory allocation, setting up how much RAM will be used in the VM. There is an option for dynamic memory where you can change based on the need. It's not enabled by default, but it is sitting right here. So a VM that has the Hyper-V tools installed and is capable of handling dynamic memory can take advantage of this. Now, I don't remember off the top of my head if memory can be over-provisioned. Storage can be over-provisioned, but I don't remember if memory can be over-provisioned in Hyper-V. but you can definitely hard add memory to any Windows hosts that have the Hyper-V tools installed. There's also smart paging, using a file on the host computer to store any memory. This functions with dynamic. Other than setting where it's going to be, that's pretty much all you can do for that. Your virtual processor, you can adjust how many virtual processors are assigned to a VM. So here's the answer to the question, can CPU be over-provisioned? Up to the total number of physical processors or processor cores installed. And then our resource control, similar to VMware. So here you go. We say how many virtual processors are going to be used. And if we want to do any resource control, we can set that all up here. Our integration service, which is basically our Hyper-V tools or VMware tools or VirtualBox, are our drivers that we need for any of our VMs to function and be able to do things like dynamic memory. Oh, I see a question. Let's say my server has 20 cores and I have 2 VMs. Can I give them 15 each? You know, I don't actually know if Hyper-V will freak out when you assign the 15 cores to the first VM and then you try assigning 15 cores to the second. It might not let you. It might freak out and say, oh, you only have 5. I know that Hyper-V is not as versatile as VMware's, but it is something definitely to test. But off the top of my head, I don't know, and my gut feeling is that it can't do that. Yeah, I think they're hard provisioned. It's worth a test to see if it is, but I think it is hard provisioned. So all the integration services here that you can apply, along with all these things that you can do with it installed in your VM. If you've ever worked with VMs, you know that snapshots can save your life. And they are here in Microsoft's Hyper-V. It's just called Checkpoint, but it functions the same way. You can have up to 50 checkpoints per VM. And you can always clean them up later as you go. Of course, creating more checkpoints will decrease the disk performance because the host has to read multiple disks at once. If you want to expand a disk, you need to get rid of all your checkpoints or snapshots. You can always revert or apply. Either way, we'll use a saved checkpoint that you have created before. So in this case, we have our initial snapshot, and then we made a second snapshot out of that one. We have a third, and we have a fourth. So we kind of broke from number 2 into 2 different ways. Again, you can go up to 50 snapshots in Hyper-V per VM. And just like with any type 1 hypervisor, you can set which VMs can automatically run when the host is brought back to life in case of a power outage or anything like that. For example, you can have a VM like this automatically start if service is stopped, or always start automatically, and how long to wait, which is ideal if we're talking running from Windows Server. You know that Windows always takes a while to boot. So you want to give the host some time to boot up all its services and be ready, and then start up your virtual machines, which will then do the same. In case of an automatic stop, you can always choose to either save the state, turn it off, or shut down the guest OS. Just like with anything else, you can always see how much your VMs are utilizing your resources, setting any minimums, maximums as needed. Oops. You can target a specific metric if you want to see, for example, how much network use is being done out of a specific VM. You can narrow it down to that, or how much processor time is being used up. You can do that. You also create resource pools to limit how much a certain system or systems can use your resources, just like you can with VMware. And then you can view after it's all set up. The enhanced session mode gives you things like audio, which it did not prior. Also printer redirection, adding USBs, extra drives, plug and play devices, copying data in and out of a VM through the clipboard. With enhanced session mode, we can choose to make our screen larger, use higher pixels. Of course, in order to do this, you need to have all the integration service already ahead of time, and you can enable it through PowerShell on the host. So here's the option after you have ensured that your hosts can handle this, and that your guests have integration services installed. There's the option to enable. Is there a Windows embedded that can run on a thin client to Hyper-V? You mean, so the thin client connects to the Hyper-V server, and it gets Windows, because Windows embedded is for IoT devices or devices that are going to be static. So maybe you're thinking of like Windows as a kiosk. You could do something like that. Although it probably would be more difficult with Hyper-V. It's easier to do on VMware with Horizon. So we kind of talked about that dynamic memory. Here is the non-uniform memory access. If we have multiprocessor systems, they could share memory for these VMs. it is possible to share within multiple systems. So if the nodes, the physical systems, now called nodes, are interconnected together and they have the same settings and they have this on, then the VMs can take advantage of that. And if they use up their memory on the host they're on, they can jump to the next host and use up more memory there. Here you see how we're going to also use some processing out through this whole topology. You can choose who can manage a Hyper-V. It can be domain administrators by default, but just as always, you never want users to have admin access because that's just bad security. So you could use the authorization managers to select certain users or certain groups to have the role needed or the permission needed to manage it without being administrators. So here we can define some roles and say who can do what. Right, you can see the question in the chat that yes, you can use the nodes. It can be used in that way as well. You also have the discrete device assignment, a feature available in 2016 to give exclusive access to the hardware devices. So we're bypassing the Hyper-V, the hypervisor completely and going straight to the physical disks. So our physical disk or physical physical hardware, for example, a Bluetooth card or a Wi-Fi card, or anything that's physically connected to the box, we can pass it up to the virtual machine direct as though it is connected to the virtual machine. And you'll need to enable it, but it is possible to do. Of course, you can manage all these systems, these virtual machines, through PowerShell. No surprise there that anything you do in the GUI can also be done within PowerShell. Cool. Any questions? Any other questions? I should really say. Awesome. So with that, we'll stop the live stream.